All right, so we're going to pick up where we left off yesterday with the shell method. So we've got one weird kind of problem to look at, and then we're going to do a comparison of the two methods. So this first one, we've got two different regions here. So we've got x squared and then 4x minus x squared. So just like with all of these other ones, in order to graph it accurately, we need to make sure that we find our intersection points. So we're going to set the x squared equal to the 4x minus x squared. So let's move everything, I guess, over to the left-hand side. So if I move over another x squared, I'll have 2x squared and then minus 4x. So with this, we can factor out a common 2x, and then we're left with x minus 2. So we know that they intersect at x equals 0, and then again at x equals 2. So we can plug that, I would plug them into the x squared, just because that's the simpler function, and then you can figure out where they meet. So if we plug 0 in to x squared, we get 0, 0, so we know where they intersect at the origin. And then if we plug 2 in, 2 squared is 4, so they're going to intersect right here at the point 24. So let's get a sketch of those two. So here's x squared. Nice and easy. And then 4x minus x squared, you know that's going to be upside down because the x squared is negative. So it doesn't need to be a flawless graph. We just need to know where they're intersecting each other. All right, so it's going to look something like this. And I think if you were to calculate it, the vertex actually is at 2. So that's the high point of our graph. So just like the previous section, I want to see a number of things. I want to see the shaded region. That's the region that you're going to end up revolving. So even if you're just lightly shading it with a pencil, whatever, I want to see exactly what you've got there. And then we've got two other things that you need to sketch in. We want to sketch in the axis of revolution. So the line x equals 2 is our axis of revolution. Very, very, very important that you know whether x equals lines are vertical or horizontal, because you will lose a lot of points that way. So x equals 2 is a vertical line. So I want you to draw that in, label it, that's your axis of revolution. And then because we're doing the shell method, your rectangle is going to be parallel to the axis of revolution. So it's the opposite of the disk method. So then draw in a parallel representative rectangle, which of course would be vertical. And so you know that because your rectangle is vertical, everything's going to be in terms of x. Okay? So we've got two things to set up. We've got p of x, and then we've got h of x. So p of x is the distance between a representative rectangle and the axis of revolution. And so this one, you're just going right minus left. Since the axis is on the right, you start with 2 and then minus, remember the rectangle is just represented by x. So 2 minus x, that's your p of x. That's going to be the distance at any point between the axis of revolution and a representative rectangle. So say the rectangle is sitting right here on the axis, 2 minus 2 would mean there's no distance at all. And if it was all the way over here at 0, 2 minus 0 would mean the distance was 2. So 2 minus x, we stick with that expression. And then the height of the rectangle is just the top minus the bottom. The top is sitting on 4x minus x squared, and the bottom is sitting on x squared. So it's basically just an upper minus lower. Okay, and we can clean that up a little bit, combine like terms. So I've got p of x, h of x. I'm just going to plug those into the formula. So volume equals, remember the shell method starts with a 2 pi, because that's part of our, it's basically the area of a rectangle, but the length of the rectangle came from the circumference formula. So you can always glance back in case you're wondering where that 2 pi came from. Okay, well the video cut me off, so you guys are going to see some writing just magically appear here. Let me kind of run you through it again. So there's the 2 pi, and then our bounds go from 0 to 2, because it intersects right here at 0, and then intersects again at 2, and then we've just got p of x times h of x. Like I said, that's all part of the area of a rectangle where one side is the circumference. So you've got the 2 pi times r times h, and all the pieces kind of fall into place there. Okay, so before we start in the comparison, which is what we're spending most of our time on, we're going to write kind of some little blurbs here, some fill in the blank. So for the disk method, if you remember from the last couple of days, the representative rectangle is always perpendicular to the axis of revolution. All right, so that's our first fill in the blank there, perpendicular. And then for the shell method, like we just did, the representative rectangle is always parallel to the axis of revolution. So just with that alone, you can get a distinction between the two methods. So basically, you're going to be given the axis of revolution, And then you don't ever want to change the function. You want to leave the function the way it is. So whether it's in terms of x or in terms of y, you can kind of choose your method based on that, which I'll explain as we look at the next problem. All right, so a function in terms of x. If you're given a function in terms of x, that would go with a vertical representative rectangle. Because remember, x equals lines are vertical lines. And then if you've got a function written in terms of y, and by written in terms of y, I mean x equals and then a bunch of y stuff. And so in terms of x means y equals and then a bunch of x stuff. So while a function in terms of y has a horizontal representative rectangle. So the first couple days, we kind of did the opposite of this. It's like we knew, okay, if I've got a horizontal axis, I'm doing the disk method, I've got a vertical representative rectangle, that means I need to do everything in terms of x. You can kind of work backward now, because you're like, all right, I'm given a function in terms of x. That means I have a vertical representative rectangle. If you have a vertical axis, that means shell method. If you have a horizontal axis, that means disk method. So this way you don't ever have to rearrange your function, which people like that a lot. So combining these two pieces, like I said, we'll talk about this in a bit, but it should be fairly obvious which method you're going to be picking. So this example, we're going to use both. So we're going to draw the sketch on here, and then let's compare the disk method and the shell method. Which one's easier, which one makes more sense, but then you'll see that we obviously get the same answer either way. So we've got root x and then x cubed. They're going to intersect at 1, 1. So let's scale this out a little bit just so you can actually see something. So let's go up 3 units. So they're going to intersect right here. So here is the square root of x. Goes through the origin and then it goes through 1, 1. And then the function x cubed looks like this. Okay, so same as always, I need to see 3 things. I want to see the shaded region. I want to see the axis of revolution, so we're revolving about the x-axis, which is this horizontal line right here. And then we're going to do both methods. So if we're going to do the disk method means we are going to have a vertical rectangle. So let's start there with the disk method, and then we'll talk about shell method. All right, so for disk method, I guess technically washer method, whatever we want to call it, we need capital R and we need lowercase r, the outer radius and the inner radius. And then we're going to talk about what happens as we revolve that. So the outer radius is the distance between the outside of the shape and the axis of revolution. The outside of the shape is marked by root x, and then the axis is 0. And then our inner radius is the inside of the shape back down to the axis of revolution, and the inside of the shape is marked by x cubed, and then minus 0. Okay, so we're going to set this up. So our volume is, we have a pi on the outside for disk method, times the integral from x equals 0 to x equals 1. And then we've got capital R, we don't need the minus 0, squared, minus lowercase r squared, and then don't forget your differential. All right, so if we plug that into our calculator, and like I said, on the videos, I'm not going to show you how to do this anymore because we've done plenty of integrals in our calculator. What we end up with is 5 pi over 14. You could always plug that in, test it out yourself. We get 5 pi over 14 by doing the disk method. So now let's switch gears and do the shell method. So same function, same axis, we're just going to switch and do a different method. If we choose to do that, with the shell method, our rectangle has to be perpendicular. So we're going to switch to doing a horizontal rectangle, which means everything's going to be in terms of y. All right, so we're going to rearrange our equations. So I'm just going to write right here. So if we solve this for x, we're going to have x equals y squared. And then if we solve this for x, we're going to have x equals the cube root of y. Okay, so just rearranging my two functions and giving them x equals instead of y equals so that I can have everything in terms of y. So for the shell method, I am going to have a p of y and an h of y. So remember, p of y is the distance between the representative rectangle and the axis of revolution. So this is just the y value. Whatever the y value is, that's the height of this rectangle. So this distance right here is just the y value and then minus 0, just because the axis is 0. And then h of y is kind of the length, I guess, or the height, depending on what orientation you're looking at. So from this tip of the rectangle back to this tip of the rectangle. Remember, when we're in terms of y, we always do right minus left. So the right function is bounded by this, the cube root of y, minus, and then the left tip of the rectangle is sitting on y squared. Okay, so we set that up. And then if we plug this into the shell method formula, the shell method starts with a 2 pi. My bounds are in terms of y, but they're still 0 to 1. And then I have p of y times h of y. Okay, so that's my setup. Plug that into the calculator, and I'm sure you are probably not surprised to see that I get the exact same answer, 5 pi over 14. So just to talk about this one really quickly, it's not that either the disk method or the shell method is easier ever. Like, it's not like, oh, the disk method is always easier. It depends on what you're given. The fact that we are given functions in terms of x and the fact that we are given a horizontal axis means that the disk method was easier, because when we did the shell method, we had to rearrange the functions. So the easiest way to do this is not rearranging the functions and just kind of letting the axis choose which method you're going to use. So let's take a look at another example that will hopefully make that make sense as well. So that's just kind of what I was saying here, is many times one of the methods is preferable. So we've got this example that we saw in the previous notes. So I'm not going to rewrite this one out, but I'm just going to kind of recap for you. This one, when we did the disk method, because we have a vertical axis of revolution, and in order to do the disk method, you had to have a horizontal representative rectangle, which means everything's in terms of y, and if everything's in terms of y, we had to rearrange these functions and write them as x equals functions instead of y equals functions. So that's already a little bit extra work than maybe we feel like doing. And then to top it off, we've got these two separate sections because capital R and lowercase r aren't always the same. When we get to the top half here, your little r is actually this parabola, whereas here there is no little r. So when we did this problem in the previous set of notes, we had to split it up into two different integrals, we had to rearrange the functions, kind of a lot of unnecessary things now that we know about the shell method. So if we look at the shell method, we've got a vertical axis of revolution, and so we can mark in a vertical, aka parallel, representative rectangle, which means we get to do everything in terms of x. So the first perk is that we don't have to rearrange the functions. The second perk is that, as you can see, the top of this rectangle is always on this function, and the bottom of this rectangle is always on this function, which means we only need one integral, which already makes this shell method like twice as good as the disk method would be. So once we plug everything in here, we're doing the shell method, we're in terms of x, so we need a p of x and we need an h of x. So p of x is the distance between the rectangle and the axis of revolution. The rectangle is always just represented by the x value, and then minus the axis, which is 0 here. And then h of x is the height of one of the representative rectangles. So the top is sitting on this function, which is x squared plus 1. And then the bottom is sitting on 0. So we don't need the zeros. I'm just trying to get you guys in the habit of doing, right minus left, upper minus lower, whatever it is, even if the lower function or the left function is 0, because eventually it won't be. So we plug this all in. So we start with the 2 pi because we're doing the shell method. My bounds are in terms of x, so I go from x equals 0 and I end at x equals 1, and then I just plug in p of x times h of x. Now this one would actually be fairly easy to do by hand, not that we're going to, but I've had people asking the last couple days if these would always appear on the calculator section of the AP test. And my answer was kind of non-committal. I said usually. This is something that could appear on the non-calculator section, something that's this easy to integrate, because all I would do is I would distribute the x, and then it's very, very basic integration. Not that I'm going to make you do that. If you plug this part in, you get 1.5. I'm sorry, if you plug this part in, you get 3/4, and then you multiply it by the 2 pi. And so we end up with 3 pi over 2 would be our answer. Remember, you're always welcome to do a decimal approximation or 1.5 times pi, or however you want to write it. Truncate, rounding, doesn't matter. The AP test will have the option of all of them on the answer key, but I just always do exact answers with pi involved. All right, so last couple of problems here. We've got one more problem and then I've got a little chart that I'm going to fill in. So this is where we see the first example where we're just going to let the axis determine what method we're going to use. So if we sketch on, we've got this graph right here, which is going to be weird. We'll talk about graphing that in just a moment. Y equals 1 and x equals 1. Let's start with those. We're going to scale everything out quite a bit too. We're going to scale by 3, just like we did a couple problems ago. So here is y equals 1. Remember, y equals lines are horizontal lines. And then x equals 1. X equals lines are vertical lines. And then we'll sketch in where the x equals 2 is, okay? So let's worry about this piece right here. So it's got a y-intercept of 1. When I plug in x equals 0, I get y equals 1. And let's plug in x equals 1. If I plug in 1, I get 1 cubed plus 1 plus 1, which is 3. So that's actually going to be, maybe I shouldn't have scaled this in hindsight. So I'm going here, and then I go up. Here is 2 and up, so 3 would be right around here. So this is the cubic function. So it kind of turns around here and then comes up like that. All right, so the region that we're talking about is this almost triangular region right here. So I want to see you sketch it in. And then here's what I would normally recommend doing. I'm never going to tell you, hey, use the disk method here, use the shell method here, but I'm going to let the functions determine the method that you're using. So our line of revolution is x equals 2. Remember, x equals lines are vertical lines. So according to my scale, that would be right around here. So this is the axis of revolution. And then because my function is in terms of x, if my function is in terms of x, and it really can't be changed, it would be impossible to get x by itself and to get it to be a function of y. So that means that I'm basically forcing myself into having a vertical representative rectangle. Remember, function in terms of x means a vertical representative rectangle. So based on what I have on my picture, I have a vertical axis, I have a vertical rectangle, they're parallel, that means shell method. So you see how knowing what my functions were and knowing what my axis was kind of predetermined what method would be best for us. So that means I am going to choose the shell method. So I need a p of x and I need an h of x. So because my axis moved, my p of x is going to be a little weird. I'm still going to do right minus left. The axis is always represented by x. My axis is 2 and my rectangle is x. So I do the axis minus the rectangle, and that's my p of x. And then h of x is the height of the rectangle. So the top edge of the rectangle is lying on x cubed plus x plus 1, and then minus the bottom edge of my rectangle is lying on y equals 1. So the 1's actually just cancel, and that is my h of x at any given value of x, because you notice as I move from left to right, my rectangle is going to change, and it's all going to be dependent on this function right here. So plug that into my volume formula. I start with a 2 pi because I'm doing the shell method. My bounds, I start at x equals 0, and then I end at x equals 1. And then I have p of x times h of x. This one actually wouldn't be too bad to do by hand either. Again, though, not that I'm going to make you. And so we plug this into the calculator. We are going to get 29 pi over 15. Like I said before, I'm not going to spend the time to show you how to do this in the calculator. All right, last little thing here is we have this chart that I'm going to have you fill out that basically just summarizes all the things that I just said. So say we have a vertical axis, which is given to you. So this part right here, this is always going to be given to you. You are never ever going to choose which axis you're going to revolve around. You'll notice the past several days it's been handed to you every time. The vertical representative rectangle, that's if you have a function of x, aka you have y equals and then a whole bunch of x stuff. If you have a horizontal representative rectangle, that means everything was given to you in terms of y, which means your functions would be x equals some sort of function of y. This is very rare. Very, very rare that you would actually be given anything as an x equals function rather than a y equals function. So this is more going to be the column that you'll focus on, but this could happen. So say you have a vertical axis, a vertical rectangle, that means they're parallel. That would lead you to the shell method. Say that you did have that rare case where you were given the horizontal representative rectangle, that would make it perpendicular to my axis, and so that would be either the disk or the washer method, depending on if your shape has a gap or not. Now down here, say you're given a function of x and you're given a horizontal axis, That means these two are parallel to each other, which means you would use either the disc or washer method, again, depending on if you had a gap. And last one, say we have that rare case where you're given everything in terms of y. If you have a horizontal axis, the axis in the rectangle would be parallel, which means you should do the shell method. All right, so keep this chart handy. Hopefully that's helpful. We're going to finish off the chapter by looking at a full day of AP problems next lesson.